What's going on? Alan here, just trying to help you guys out with another section of Trig. Now we're going to talk about non-acute angles, meaning outside of quadrant one in our 0 to 90. So we're going to keep piggybacking off of all of the things that we've been talking about, and I know I've mentioned it quite a few times already, but this again is one of the most important concepts moving forward. We're just going to keep building on important concept at the beginning of this. So if I had to pick one section, and again, they're all related, but this one for me and the way that I teach trig is the most important because it's going to introduce this new topic called a reference angle. All right. So I'll try to stop saying every one of these is the most important, but like I mentioned, this, if I had to choose one, very, very important for our progress moving forward. So it's going to piggyback off of what we just went over. So I'll throw a little review in there for you, but this one, not so heavy on the derivations or proofs, but very important here at the beginning. So I'll try to keep it short and sweet. So when building these angles throughout our entire circle, if we were to go from the positive x-axis and rotate any direction, whether we're in quadrant one, quadrant two, quadrant three, or all the way almost around to quadrant four, we're going to be looking at building triangles again. After all, this is trig. So we're going to be talking about this thing called a reference angle. Because as I mentioned before, we're going to be doing everything with reference to our positive x-axis. Okay? So in order to build what we've been talking about, which are all these acute angles between 0 and 90, no matter if I put you in quadrants 2, 3, or 4, which aren't acute angles, say 120 degrees, for example, if you had to travel that, then you know that you could go 90 plus 30 more to get there, or you also could have gone 180 and then came back 60 degrees to get that 120 degrees. So either way, notice you'd be at that same point of reference. Now, if I wanted to go back that 60 degrees from my 180, you can see either way I have a really nice angle if I was to build a triangle. Now here's the option. You could actually build that triangle with the red one perpendicular to the y-axis, and you'd have a nice 30, 60, 90. Or we could have drawn it down to the x-axis and dropped that perpendicular and had a 30, 60, 90. So you can see why in the last video we talked so much about those special right triangles, 45, 45, 90, and the 30, 60, 90. Because those ratios work really well with all of our trig functions because we know the side lengths of each one of those 30, 60, and 45, 45, 90 right triangles. So what we're going to do is we're going to have to decide, do we want to draw it to the y-axis, perpendicular up and down, or do we want to draw it to the x-axis? What they decided was, since we started with the x-axis, we'll always draw to the x-axis. So that is the key that you know. Everything for this class is going to be drawn to the x-axis, what we call our reference axis for these reference angles. So when I'm looking at this 120 degree angle, I'm actually going to use this fact. And again, whether I went 90 plus 30 to get that with the red, either way, I can then find the remaining part of that angle. And that is going to be what is called the reference angle. And we're going to use this little moniker here to actually label that it's, hey, not actually 60 degrees that we went, because that wouldn't put me in quadrant two. It was actually 120 degrees. But I'm going to draw this right triangle that got me all the way to this point, but I'm actually going to use this reference angle to my reference axis here. And so therefore we can then find sine, cosine, tangent of 120 degrees, which don't also forget that we utilized the fact that all students take calculus. And we know the only trig function that would be positive is sine. And of course, its reciprocal function, which would be cosecant. All right? So that's what we mean by reference angles. So when they tell us to do some angle theta, like I gave you 120 degrees, then we're going to rotate that. And that's going to put us in quadrant 2. But we're going to actually draw and keep the acute, the smaller angle, down to the x-axis so that we can create our right triangle and hopefully have a really nice angle like a 30, a 45, or a 60 to work with. Okay? So the easiest way is to not do 90 plus 30 and then see what's left. It's always, since we're going to be drawing it to the x-axis, is to use the 180 degrees and then see how much you have to come back, because that number then gives you your reference angle. Now, you don't need a reference angle between 0 and 90 in quadrant 1 because it's already an acute angle. So in quadrant 2, we're going to use 180 and subtract that angle of 120 that we had to go to see what our reference angle of 60 would be. That's what this is saying. All right? But if we're in quadrant 3, then we're going to have to go that 180 plus a little bit more. So to find the difference there, we'll now take the bigger angle, which would be our theta that they asked us to go, and we'll subtract off that 180 to see what's left. Okay? And then to go all the way to quadrant 4, we're going to take and use the other side of the reference angles, and that is our 360 degrees. We don't need 0 because everything from here to here is already acute. So quadrant 1 is our favorite, of course, but 2, 3, and 4, we're going to have to get it to feel like quadrant 1, a nice acute angle. And again, we're going to hope for a 30, a 45, or a 60. Okay, so since we would not have to rotate all the way around 360 degrees, we're going to have to see how much we would come back, and that would give us our reference angle there. All right, so that would be, to find that reference angle, 360 minus whatever they want us to go. So those are what are called reference angles. I'm going to refer to it, no pun intended, over and over and over again. Very, very important concept that you can get away with a lot less memorization if you just memorize these few things. Okay? So again, a common mistake I wanted to warn you all about, little word of caution here. Always do it to the x-axis, as I mentioned before. Okay? You can always do it to the y-axis, but for us, we are not going to. So make sure that you don't. Only the x-axis. So what I want you to do now is actually try to find what the reference angle would be for each of our big 3 reference angles. Not even adding in trig functions yet. So a 30, a 45, and a 60. How could you find the reference angles in each one of those various quadrants? So drawing that in for you, I'll start with the 30-degree angle, which means I would also want a 30-degree angle here in quadrant 2, another one in quadrant 3, and another one in quadrant 4. And so remember, we're definitely going to be utilizing the 180 and the 360. So we already know that we have the 30-degree in quadrant 1. That is what we're going to call our reference angle. So in quadrant 2, what would we have to do? Well, remember, we'd have to go 180 and then back 30, which would be, hopefully you said 150 degrees. Then instead of going back 30 degrees, when we rotate around, now we're going to go 180 plus an extra 30 degrees. So in quadrant 3, we would have to take and add 30 to our 180, which would be 210 degrees. And then lastly, we would rotate pretty far, but I don't want to go 270 and then try to figure out how much more to get to that angle. I'm going to go all the way around 360 and then come back 30. So you're just taking 360 less 30, which is 330 degrees. Okay, so we're going to have to do that for all of these reference angles, the 30, the 45, and the 60. And again, we chose those because we know all three of their side lengths for those special right triangles. So the next thing we're going to do is the 45 degree. So instead of those being 30-degree angles in there, we would now draw 45s, which are right down the middle, because we know each one of those is 90-degree angles. So this would be a 45 here. This would be a 45 there, there, and there. And remember, I'm only doing those ones, not the ones that I haven't done anything with, because these ones would be referenced to the y-axis. We're doing everything to the x. So when we take this value of 45-degree angle, we can then drop down that point a right angle perpendicular and have a 45, 45, 90, and then we should be able to find any of our 6 trig functions, especially the big 3. So obviously, we are starting with the 45 degree, and therefore I would have to go 180 for quadrant 2, less 40, and then less 5. And I say it like that because I can do that in my head. 180 less 40 is 140, less 5 more, 135 degrees. Quadrant 3, we'll go 180 plus 45, which the 180 plus 40 is 220, plus 5 more, 225. So hopefully you're kind of getting the idea. Now we're going to take 360 to go to quadrant 4, and we're going to subtract 45 because we don't want to rotate all the way around 360. We want to come back that 45. So again, do that in your head. 360 less 40, 320, minus 5 more, 315 degrees. And so why are we even taking the time to write this stuff down? Because you will see these often, okay? Because they will give us our nice reference angles. So the last one here is going to be a 60-degree reference angle. And again, remember, always to the x-axis, trying to hit that point home. So go ahead and try to do this quickly, and I'll give you the answers after you give it a try on your own. So go ahead and pause it. All right, we got a reference angle of 60. Now we're going to do 180 minus 60 now, which would be 120. Then we'll take, for quadrant 3, 180 plus 60 more, which doing that, you're really just looking at the 18 and the 6, and you get 24. And then the last one, 360 will take us all the way around. So we want to come back 60. Easiest one here, 300 degrees for all you Spartans out there. All right. Pretty simple stuff. The only reason I even gave you these is because now, instead of only seeing the 30, the 45, and the 60, we're also going to start seeing these other forms of our 30-degree angle in different quadrants, our 45-degree angle in different quadrants, and even our 60-degree angle in any of our other 3 quadrants. Okay? So before we get to the examples, I wanted to do one more thing with you all. And that is ask you to quickly fill this chart out one more time. All right. If you already have these memorized, beautiful. If not, start working on it. Okay. Create flashcards, whatever you have to do. Remember, I likened this table to your multiplication table in elementary. Okay. So really in trig and beyond, it's going to pay dividends for you to know these values off the top of your head like that. All right, so do me a favor, pause it real quick. If you need to do it using that quick little shortcut that I showed you, great. If not, I'll do it for you one more time and explain it. And then from there, it's on you to memorize these things, because then we're just going to start using them over and over and over again. All right, quick pause. See if you can fill this out as quickly as possible. And then I'll go ahead and explain it one more time to fill it out with you. And then you can take the time to memorize it after that. All right, pause it. All right, hopefully you're able to build this thing. I'm going to go ahead and do it with you all real quick with the explanations. one more time. And remember, it does matter how you set this up. So make sure that you have your sine, cosine, tangent listed from top to bottom, and then left to right, 0, 30, 45, 60, 90 are acute angles in quadrant 1 from 0 to 90, which makes up the borderlines of quadrant 1. All right, so starting with sine, remember, since we're starting at 0, we're going to start with 0 and then just increase by 1 each time. Now remember, the next row is called cosine, which is the complement of that. So remember, complementary angles are when two angles add up to 90. So now we're just going to do this in reverse order and say 0, 1, 2, 3, and 4, because they're complements of each other. And remember, if you know this, then it will save you half the time that it normally would take you to do this. You just got to make sure that you remember to take the square root of the tops of each one of these. And once you've done that, you're done with sine and cosine. All you'd have to do is clean it up a little bit. And the cleaning up that you can do is obviously this is a 0, therefore this is a 0. This is a square root of 4, which is 2 over 2, so this is a 1, therefore this is a 1. And all the rest of those are our values, other than you can write this as 1/2, because we know the square root of 1 as well. Okay? So again, very clean, very easy. Hopefully you feel that way to build. The only thing we also have to build is tangent. And so remember, tangent is just sine over cosine. So if we just take 0 over 1, we get 0. If we take 1 over 0, that's undefined. And if we take the square root of 2 over the square root of 2, that is itself, so we get 1. Then, because the other two involve a 30, 60, 90 triangle, we know the root 3's are going to be involved. And since 30 is smaller, and we're using the 30, 60, 90, not the 45, 45, which has the two angles that are the same, that's why it has the root 2 involved, then I know because the 30 is smaller, it's going to be divided by 3, where the 60 is not. All right? And then you have every single reference angle, including the two quadrantals, 0 and 90, for the big three trig functions, sine, cosine, and tangent, which means we're set to be able to evaluate any angle with these reference angles in any quadrant. And that includes sine, cosine, tangents, reciprocal function, cosecant, secant, and cotangent. All right? So not a whole lot new in this section, but still have to really try to harp home to memorize all of these, because the quicker you memorize these, then the easier this class is going to be as we continue adding more and more things to these.